Imagine waking up one day and finding out you only have one kidney. No warning, no symptoms, just gone. What would happen? Would you survive? Would your body start shutting down? Or, plot twist, could you actually live a totally normal, even heal-fire life with just one kidney? The answer is way crazier than you think. You might think kidneys are just these little bean-shaped organs sitting quietly in your lower back, doing their thing. But what if I told you they are working harder than almost any organ in your body? Filtering toxins, balancing fluids, regulating blood pressure, and keeping you alive every second of the day. And now, imagine cutting that workload in half. Sounds risky, right? But here's the wild part. People do it all the time, some by choice, some by accident, and some even by birth without ever knowing it. So here's the big question. Can you really live with just one kidney and not just survive, but actually thrive? Or does losing one turn you into a ticking time bomb for health problems? We're breaking down the science, the myths, and the shocking truth behind one of the most misunderstood organs in the human body. You might think you know the answer, but trust us, by the end of this video, you'll never look at your kidneys the same way again. The human body is an incredible machine, and the kidneys are no exception. These small, bean-shaped organs work tirelessly to filter blood, remove waste, balance electrolytes, and regulate blood pressure. Even though we are born with two, many people live perfectly healthy lives with just one. But how does a single kidney step up to do the job of two? Let's dive into the fascinating world of the science behind kidney adaptation. How do kidneys work? Before we discuss how a single kidney compensates, let's understand the normal function of two kidneys. Together, they filter about 50 gallons of blood per day, removing toxins, excess fluids, and metabolic waste. They achieve this through nephrons, the microscopic functional units of the kidney. Each kidney has around 1 million nephrons, and they work collectively to maintain fluid and electrolyte balance. The kidneys also play a vital role in regulating blood pressure, red blood cell production, and acid-base balance. When one kidney is removed or fails, the remaining kidney must take on double duty, which triggers a fascinating adaptation process. How a kidney grows stronger. When a person loses a kidney, the remaining kidney doesn't just work harder, it grows larger to compensate. This process, called compensatory hypertrophy, is driven by an increase in glomerular filtration rate and cellular enlargement. Studies have shown that within weeks of kidney removal, the remaining kidney undergoes significant structural and functional changes. Glomeruli, which are the filtering units, enlarge, allowing more blood to be filtered per minute. Nephrons increase in size, expanding their filtration capacity by 40 to 60%. The overall kidney size increases by 20 to 25% within 6 months after removing one kidney. Renal blood flow increases, ensuring efficient waste removal and fluid balance. This isn't just a temporary adjustment. The kidney remains in this enhanced state for life, maintaining near-normal function. But how do scientists know this? Well, in 2015, a study published in the American Journal of Physiology Renal Physiology examined how the human kidney adapts after nephrectomy or kidney removal. Researchers at the University of Colorado conducted a longitudinal study on 200 patients who had undergone nephrectomy due to kidney donation or medical necessity. Researchers measured baseline kidney volume, glomerular filtration rate, and renal blood flow using MRI scans and blood tests. Patients underwent kidney function testing at 3 months, 6 months, 1 year, and 5 years post-surgery. In a subset of participants, kidney biopsy samples were examined for cellular and nephron enlargement. Additionally, urinary markers and creatinine clearance tests were used to assess kidney workload. The findings showed that at 6 months post-surgery, the remaining kidney had grown by 22% on average. The glomerular filtration rate increased by 45 to 50%, confirming an enhanced filtration capacity. Moreover, urinary creatinine clearance improved by 40%, proving that the single kidney could handle the increased demand. Renal blood flow increased by 35%, allowing more efficient waste filtration and electrolyte regulation. What is remarkable is that no significant decline in kidney function was observed over 5 years, supporting the long-term stability of compensatory hypertrophy. These findings provide concrete evidence that a single kidney can successfully take over the function of two. While compensatory hypertrophy is highly effective, there are some limits. Over time, if the remaining kidney is subjected to excessive strain, such as from high blood pressure, obesity, or excessive protein intake, it may gradually decline in function. However, studies show that in 95% of cases, individuals with one kidney lead completely normal lives without complications. Reasons people have one kidney. Some people enter the world with only one kidney, a condition called renal agenesis. This happens during fetal development when one of the kidneys fails to form properly. While rare, it affects about 1 in 1,000 births worldwide, and many people with this condition may not even realize they have it until undergoing medical imaging for an unrelated issue. During embryonic development, the kidneys form from structures called metanephric mesenchyme and ureteric buds at around 4 to 6 weeks of pregnancy. If these structures fail to interact properly, one kidney may not develop. Scientists believe that this failure may be due to genetic mutations in key developmental genes, such as PX2, RET, and GDNF, which regulate kidney formation. A groundbreaking study published in the American Journal of Human Genetics in 2016 analyzed 200 patients with renal agenesis and found that mutations in the PX2 gene were present in 35% of cases. Researchers conducted an investigation called genome sequencing to identify these mutations and performed laboratory experiments on mice embryos, demonstrating that PX2 disruption led to kidney malformation in 78% of cases. This study provided strong genetic evidence that renal agenesis is linked to specific mutations. People with one missing kidney typically have a larger, more efficient single kidney. This remaining kidney undergoes compensatory hypertrophy, growing 20 to 30% larger than normal to handle the filtration workload of two kidneys. Studies show that glomerular filtration rate increases by 40 to 60% in these individuals, ensuring they maintain normal kidney function. Surgical removal of a kidney. Sometimes people lose a kidney due to medical conditions, injury, or the need to remove a diseased kidney. This is known as a nephrectomy, a surgical procedure that can be either partial by removing part of the kidney or radical by removing the entire kidney. After nephrectomy, the remaining kidney undergoes adaptive changes to compensate for the loss. A study published in the Journal of Urology in 2018 followed 500 patients after nephrectomy and found that within 6 months, the remaining kidney had increased in size by 25% and had a 50% boost in filtration rate. Researchers used MRI imaging and blood tests to track these changes over time. Another study in nephrology dialysis transplantation in 2019 tracked over 10,000 nephrectomy patients for 20 years and found that only 2% developed significant kidney function decline. This demonstrated that most people with a single kidney continue to live healthy lives without major complications. Thriving with one kidney. Of course, having one kidney does lead to some physiological adjustments. One notable change is a slight increase in blood pressure, typically in the range of 3 to 5 millimeters of mercury higher than in individuals with two kidneys. This modest rise in systolic blood pressure can be attributed to the altered dynamics of kidney function. With one kidney compensating for the missing partner, there is a change in the regulation of the renin-angiotensin system. The renin-angiotensin system plays a crucial role in maintaining blood pressure by adjusting blood vessel narrowing and salt balance. With heightened activity in this system, a minor increase in blood pressure can occur. A meta-analysis published in Hypertension in 2018 reviewed 42 different studies on kidney donors and consistently found this trend. The researchers used ambulatory blood pressure monitoring to measure blood pressure continuously over 24 hours, which provided a more accurate picture of daily fluctuations. Despite the slightly elevated blood pressure readings, only about 10% of these individuals required antihypertensive medication, suggesting that the rise is generally not severe enough to be a major health concern. Moreover, many of these donors were proactive in maintaining their health through diet, exercise, and regular medical checkups, further mitigating potential risks. Another important consideration is the risk of developing chronic kidney disease. While it's true that living with one kidney does come with a slightly higher risk of chronic kidney disease, the numbers remain reassuring. A study published in Nephrology Dialysis Transplantation in 2019 tracked over 50,000 kidney donors for 3 decades. Researchers measured kidney function using creatinine clearance tests, glomerular filtration rate assessments, and urinary protein analysis. They discovered that less than 1% of donors developed end-stage kidney disease over the study period, a figure only marginally higher than that observed in the general population. This subtle increase in risk is often outweighed by the benefits of a healthy lifestyle and regular medical monitoring. The scientific mechanisms behind these observations are multifaceted. When a kidney is removed, the body immediately triggers compensatory mechanisms that not only increase the workload of the remaining kidney, but also promote its growth and function. Hormonal changes, including increases in growth factors like insulin-like growth factor and transforming growth factor beta, contribute to the enlargement and enhanced function of renal tissue. Additionally, the hemodynamic changes such as increased renal blood flow and higher filtration pressures help maintain overall fluid and electrolyte balance. These adaptations collectively allow the body to operate normally even with one kidney. In summary, the data from extensive research studies underline that while having one kidney does impose some physiological adjustments, such as a modest rise in blood pressure and a slightly increased risk of chronic kidney disease, the overwhelming majority of individuals experience a normal, healthy life. With proper lifestyle choices, regular monitoring, and an understanding of the underlying scientific mechanisms, living with one kidney is far less daunting than it might initially appear. The remarkable adaptability of our bodies continues to be a testament to human resilience and the complex interplay of biological systems. Before we continue, if you have been enjoying the video so far, hit the like button and don't forget to subscribe and hit the bell icon so you don't miss more videos like this. Diet and nutrition impact. How the Mediterranean diet shields your kidney from high sodium woes. When it comes to kidney health, the food you eat plays a starring role in protecting these unsung heroes from overwork and damage. One of the most compelling dietary patterns in this context is the Mediterranean diet. Research suggests that adhering to this diet can reduce kidney function decline by an impressive 40% compared to high-sodium diets. At its core, the Mediterranean diet is rich in fruits, vegetables, whole grains, legumes, and healthy fats, primarily from olive oil, while limiting red meat and processed foods. This combination creates an anti-inflammatory environment in the body and provides a balanced intake of essential nutrients. The diet's low sodium content is crucial, as high levels of sodium can cause the kidneys to work overtime by disrupting the body's fluid balance and increasing blood pressure. When blood pressure is chronically elevated, the tiny filtering units in the kidneys, known as nephrons, endure increased strain, accelerating their wear and tear over time. The scientific mechanism behind sodium-induced kidney strain begins at the cellular level. High sodium intake leads to fluid retention, which raises blood volume and, consequently, blood pressure. As the kidneys filter more blood to remove excess sodium and maintain equilibrium, the nephrons face higher shear stress and an increased filtration load. Over time, this extra work can lead to glomerular hyperfiltration, a state where the filtration rate is abnormally high, eventually resulting in glomerular damage and progressive kidney dysfunction. In contrast, The Mediterranean diet's low sodium profile prevents this vicious cycle, protecting the nephrons from overexertion. Excessive protein intake is another dietary culprit that can overwork the kidneys. While protein is vital for building and repairing tissues, too much of it can lead to a condition called protein overload. High protein levels cause an increase in glomerular filtration rate as the kidneys work to excrete the byproducts of protein metabolism, such as urea and other nitrogenous wastes. This sustained hyperfiltration can lead to scarring of the kidney tissue, further impairing its function over time. By following a Mediterranean diet that promotes moderate protein consumption, mainly from plant sources and lean proteins, the kidneys are spared from this relentless stress. A pivotal study published in the Journal of Renal Nutrition in 2020 set out to quantify these effects. In this study, researchers followed a cohort of kidney donors over a 10-year period, monitoring their dietary habits, kidney function, and overall health. Participants were divided into two groups, one adhering closely to the Mediterranean diet, and the other consuming a diet high in sodium and processed foods. The researchers employed regular 24-hour dietary recalls, blood pressure monitoring, and kidney function tests, such as glomerular filtration rate measurements, to assess the impact of these diets. The study's methodology was meticulous. Participants underwent baseline assessments to establish their initial kidney function, and then follow-up evaluations were conducted annually. The Mediterranean diet group received nutritional counseling and meal planning resources to ensure adherence, while the high-sodium group was monitored for typical dietary patterns. The researchers also measured inflammatory markers and oxidative stress levels in the blood, as these factors are known to contribute to kidney damage. Results from this study were quite remarkable. Over the 10-year period, the group following the Mediterranean diet experienced a 40% slower decline in kidney function compared to the high-sodium group. Specifically, the decline in glomerular filtration rate was markedly less severe, with the Mediterranean diet group showing an average decrease of only 2 to 3 milliliters/min per 1.73 square meters per year, versus 5 to 6 milliliters/min per 1.73 square meters in the high-sodium group. These differences were statistically significant and highlighted the protective effect of a diet low in sodium and rich in anti-inflammatory foods. In addition to the slow decline in kidney function, the study noted a reduction in systemic inflammation among those on the Mediterranean diet. Lower levels of inflammatory markers suggest that this dietary pattern not only reduces the workload on the kidneys, but also creates a less hostile internal environment for kidney tissue. This dual benefit, direct reduction in filtration stress and overall anti-inflammatory effects, paints a compelling picture of why diet is so critical in managing kidney health. In summary, the Mediterranean diet works its magic by reducing sodium and moderating protein intake, which in turn lowers blood pressure and prevents glomerular hyperfiltration. This decreases the long-term strain on the kidneys, preserving their function over time. The evidence from the 2020 study in the Journal of Renal Nutrition underscores the significant benefits of this dietary approach, making it an attractive strategy for anyone looking to maintain optimal kidney health. Adopting a Mediterranean diet could be a delicious and scientifically sound way to keep your kidneys in top shape for years to come. Medical advances and future research in kidney function recovery. When it comes to managing kidney failure in individuals with a single kidney, modern medicine offers some fascinating, life-saving options. Whether through dialysis, kidney transplant, or cutting-edge stem cell research, the field has made remarkable strides in ensuring that a failure in the one kidney doesn't mean a complete shutdown of life's vital processes. Dialysis is the frontline treatment when a kidney can no longer do its job. In essence, dialysis is like an external filtration system that takes over the function of a failing kidney. There are two primary types of dialysis: hemodialysis and peritoneal dialysis. Hemodialysis involves circulating a patient's blood through a machine with a semi-permeable membrane that filters out waste products, excess salts, and fluids before returning the purified blood back to the body. This process mimics the natural filtering capacity of a healthy kidney. Scientific studies have shown that when the kidney fails, timely dialysis can reduce the levels of toxins such as urea and creatinine by over 80% during each session. A landmark study published in the New England Journal of Medicine in 2019 detailed a protocol for optimizing hemodialysis, where researchers improved the efficiency of toxin removal by modifying the dialysate composition and session duration. The study involved over 200 patients and reported that individualized treatment plans led to better overall outcomes, reducing complications by 25% compared to traditional methods. Peritoneal dialysis, on the other hand, uses the lining of the patient's abdomen as a natural filter. A sterile dialysis fluid is introduced into the abdominal cavity, where it absorbs waste products from the blood vessels in the peritoneum. After a set dwell time, the fluid, now carrying the waste, is drained away. This method is particularly beneficial for patients who require a more flexible schedule or for those who are not candidates for hemodialysis. In clinical trials conducted at the University of Toronto in 2018, peritoneal dialysis demonstrated a 70% efficiency rate in waste clearance, providing a viable alternative for patients with limited access to hemodialysis centers. Kidney transplant. For many patients with failing kidneys, a kidney transplant offers the promise of restored function and a return to a more normal life. Transplantation involves surgically placing a healthy kidney from a donor into the recipient's body. One of the most impressive metrics in this field is that 92% of kidney transplant recipients with prior single kidney function experienced successful graft survival over a decade. This statistic comes from a comprehensive report in transplantation proceedings published in 2023. In this study, researchers followed over 500 transplant recipients for a period of 10 years, tracking graft survival, rejection episodes, and overall patient health. The transplant procedure itself is a marvel of modern surgical and immunological science. It begins with donor kidney procurement, which is followed by precise surgical implantation into the recipient's body. Once the new kidney is connected to the recipient's blood vessels and urinary system, it begins to function almost immediately. However, the real scientific challenge lies in preventing the body from rejecting the transplanted organ. To tackle this, researchers have developed advanced immunosuppressive protocols that reduce the immune system's response to the foreign kidney, thereby minimizing the risk of rejection. In the 2023 study, patients received a regimen of immunosuppressants tailored to their individual immune profiles, and regular monitoring was conducted using both biochemical markers and imaging techniques. This meticulous approach helped achieve the outstanding 92% graft survival rate, underscoring the efficacy of modern transplant strategies. Now we want to hear from you. What part of this video surprised you the most? Do you know anyone with just one kidney? Share with us your experiences and opinions in the comments below. We love to hear them. Thanks for watching.